So today we are going to learn a concept called memory banking. Okay, a memory banking is a concept comes in 8086. If you see any RAM, a recent RAM nowadays, okay, if you can see it, this is one of the RAM available in our computers. It looks like this. Okay, there are 8 chips on it. Now this is a sticker which contains 2 more chips. So it is a 8 chip on this RAM. Can you tell me why there are 8 chips on this? Is there any reason? No, for it looks better. That's why. No. Then it contains the concept of memory banking. Your current processors are of 64-bit. Yes, each chip can carry a data of 8-bit. 8 is a 64. On a single time, you can fetch 64-bit of data. That's why this memory, this RAM is look like this. Understand? So here also you have a concept of memory banking, which started in 8086. So now we are going to learn what is 8086, what is memory banking, so you can understand. Understand? Clear what we are going to discuss? Okay, now first of all, what is memory banking? First question. A memory banking in which your full memory, how much memory you are available in 8086? In 8086, we are having 20-bit address bus, 2 raised to 20, 1 MB. So we are having total of 1 MB of memory, right? That full 1 MB of memory of 8086 is divided into 2 parts: odd bank, even bank. One part will contain all odd addresses, one part will contain all even addresses. One is called odd bank, one is called even bank. Right? If I divide full 1 MB into 2 parts, 512 KB, 512 KB. So there are 2 parts and they are called memory banks. Understand? Clear? They have divided their full memory of 1 MB into 2 parts. Half, half. 512, 512. Clear? Yes?
Yes, sir.
Why you need to do that? First question is why you have divided your full memory into 2 parts. Can't you make a single part and use it? Answer is no. Why? Because 8086 is 16-bit processor. Okay? What do you mean by 16-bit processor? You can access 16-bit of data in a single clock cycle. Yes? We have already discussed that if this is my memory, each location can carry how many bit data? Each location can carry only 8-bit data. Yes? So if I need 16-bit, I need to access 2 locations. Yes? Yes. On address bus, if you want to access something from 2 locations, you need to access 2 locations, right? But if you want to access something from 2 locations, there are 2 different addresses of that 2 locations, right? In address bus, at a time you can carry only one address pattern. Understand? So if I want to access 2 locations, I need to put one address, fetch the data, I need to put another address, fetch the data. So 16-bit operation can be performed only in 2 clock cycles. It can't be performed in 1 clock cycle. Understand the problem? What's the problem? The problem is they have introduced the concept of memory banking. Why? Because they want to access 16-bit of data. Yes? Yes. What was the problem in accessing 16-bit of data? You are having 2 locations which can carry 8-bit data, consecutive locations, right? So if you want to access 16-bit data, first you need to access this memory location, then you access this memory location, then you can get 16-bit of data. It is not practically possible to fetch 2 memory locations in a single clock cycle. Why? To access a memory location, you need to give the memory address. That memory address you are giving in a address bus. That address bus in a single clock cycle can carry only one address. Understand? Yes? Right? So practically it is impossible to fetch 2 locations of same memory chip in a single clock cycle. Yes? So I don't get the advantage of doing 16-bit operation. I can't do 16-bit operation in single clock cycle. That's the first problem. Clear? What's the solution? You may argue that instead of this 8-bit data, if my memory can contain 16-bit data in single clock, then to solve the purpose, I will send one address bus, it will point on one location which is of 16 bit, fetch that 16 bit in a single slot. Yes. समझ पड़ी? Will this serve the purpose? What's the problem? Problem is one location is having only 8 bit, right? That was the problem. Because of that, we need to fetch two locations, which is actually practically not possible because two locations require two address. Two address can't go in single clock cycle, so I require two clock cycles. So that's the issue. Solution can be this. In memory, each location is of 16 bit. So if I give one address, I can access 16 bit of data. Fine. Solve the purpose? No. It looks easy, but it is not the solution. That's why we are having memory banking. What's the problem with this? If you go by same concept like this, our current processors which are of 64 bit, in that case, each location is of 64 bit data. Yes. If you want to apply the same concept to our current processors, your memory should have each location with 64 bit of data. Yes. Now what if you want to store only 8 bit of data in particular location? In that case, you will store 8 bit of data over here, and all other memory will get wasted. You can't use. Understand? Understand the problem? If I am having a memory like this, where each location is of 16 bit, if I want to store only 8 bit of data, which will get stored over here, this other part will get wasted. First problem. Understand? Yes. Yes. So if you think in terms of gigabytes, you are losing so much memory. Yes. So if you put your memory locations bigger, there are more chances that your memory will get wasted. Yes. Second thing is, I now compulsorily need to use 16-bit operations. I can't perform 8-bit operations. Yes, because each location is of 16-bit. So if I do addition, subtraction, I need to do it with 16-bit of data, because every time I will get data, it is of 16-bit. Understand? So now if you make your location 16-bit, it will make you compulsorily to use 16-bit data for all the operations, right? But what we want if we should able to do 8-bit operation also, we should able to do 16-bit operation also. Understand? Suppose my processor is of 64-bit, that doesn't mean that all my processing should be done on 64-bit of data. It should allow me to do 8-bit operation also, 16-bit operation also, 24-bit operation also. Understand? If you want to do that, this solution will not work. Clear? Understand? Problem with your basic solution? Yes or no? What's the problem? First, each memory location carry 8-bit of data in 8086 or even in current processor also, right? So if you want to do 16-bit operation, you need to fetch two locations. If you want to do fetch two locations, you need to give two addresses. If you want to give two addresses, you need to use two clock pulses. Okay? In single clock pulse, only one address can be. You can't give two addresses, right? That's the issue. What we want to perform 16-bit operation in single clock cycle, right? So what they have done, they have divided memory into two parts, right? One location stored over here, one location stored over here, right? So if I pass a single address, still I can access two different chips and access the 16-bit data at a time. Understand? Now how that occurs, that we'll study. But this is what happens. The basic solution to this problem is, instead of using 8-bit location, you can use 16-bit location. What's the problem with this method? First, memory can get wasted. Second, you compulsorily need to use 16-bit operations, right? That you don't want. You want to do 8-bit operation also, you want to do 16-bit operation also. Yes? Okay. So, this is the reason, this is the background why you are having memory banking concepts. Clear? Why this concept is introduced? This is the problem. Understand the problem. If you don't understand the problem, it is useless to teach you the further things. Clear? Done? Okay. Now, what happens with this memory? So, before going to this, just consider that you are having a 3-bit of address bus. In 8086, we are having how many bit address bus? 20-bit address bus, right? So how many addresses we can give? 2 raised to 20. Suppose right now I am having 3 bit address bus. How many different address I can give? 2 raised to 3. 2 raised to 3 is 8. I can give how many different operations like addresses? 8. Okay. If I use the memory bank concept, if I divide my memory into 2 parts, now these are my 2 parts. Even bank, this is my order. What that means? My address 0, 0, 0 will store over here. 0, 0, no 0, 0, 0, 1, 0, 1, 0, 0. These are my even addresses. This is representing 0, 2, 4. 1 will be stored in 0, 0, 1. 0, 1, 1. 1, 1, 1. This is my 1. This is 7. This is 5. Where is 3? This is 3, right? And where is 5? This is 5. And this must be 4. Now, where is 6? This is my 6. And this is my. These are my 8 addresses. Yes? Yes? This is how your memory is divided. Keep in mind, this is how your memory is divided into 2 parts. One part will contain all even addresses. One part will contain all odd addresses. Yes? Okay. These are 2 different chips. What that means? If I want 8K of memory, I will buy 2 chips. 4K, 4K. One with even address, one with odd address. Clear? Yes? Now why is it so? Now concentrate with. Dhyan dejiye. If these are 3 lines, it can be A0, A1, A2. Same way. A0, A1, A2. So your processor is having only 3 address bus. A0, A1, A2. If you see it carefully, see it very carefully. In both these things, what is different? A0. If you can see it like properly, if A0 is 0, my even bank will get selected. If my A0 is 1, odd bank will get selected. Yes? Yes? If I give address 0, 0, these 2 locations get selected. If I give address 0, 1, these 2 locations get accessed. If I give 1, 1, understand? So A0 part will decide which bank to select, and other address will give you 2 locations. Yes? Yes? Samajh padi? So in the address bus of 3 bit, A0 will decide which bank to select, and A1 and A2 will decide which location to select. Understand? Your A0 line is selecting your bank, and all other lines will select your location in a bank. Clear? Yes? Now there is a concept called aligned and misaligned data. Okay, so if you can give me a textbook, we'll show you. Note. So this is my, actually if you can treat my bank, all even addresses, all odd addresses. Understand? This is called aligned data. What do you mean by aligned data? If I am reading on this, I can read on this page also at the same time. Yes? This is called aligned. If I take this page, this is misaligned. Why? I need to move. Understand? Yes. What is aligned? On a same line. What is misaligned? On a different line. Okay. Now how that helps? Concentrate here. If this is aligned data, this is aligned data. Why aligned? Because this address and this address is same. So if I give A0 as 0 or 1, but if I give A1 and A2 as 0, 0, both these lines can get selected. Yes? What is aligned? Forget about A0. Take your other lines. If I give 0, 0, this and this, both will get selected. If I give 1, 1, this is 1, 1, this is 1, both will get selected, right? So they are on the same page, so they are called aligned data. What that means? I can access 0 and 1 location together. I can access 2 2 and 3 location together. I can access 4 and 5 location together. I can access 6 and 7 together. This is called aligned data. So if my instruction will look like this, move ax comma square bracket 0 0 0 1 0. It starts with E1 address. This is aligned data. So 2-bit data will go directly because here 0 0 1 0 0 0 1 1. These two locations are used, which are aligned on same line. Understand? But consider here. If I want to access this and this, data are different. Yes, if I want to access 3 and 4, though both are consecutive, so I can access 16-bit operation, right? 8086 will allow you to do 16-bit operation on any two consecutive locations. Yes, yes, because 8086 is 16-bit processor, right? You can always access only consecutive data. You can't access random data in 16-bit operation. If you want to access this location and this location in single clock cycle, not possible. Clear? 16-bit operation together is only possible with consecutive data, right? Consecutive data means 0, 1, 2, 3, 4, 5, even 1, 2 are consecutive data. Understand? Problem with 1, 2 is what? Here in 1 it is 0, 0, in 2 it is 0, 1. Again the same problem. In single address bus, you can't pass two different addresses. Yes? So though they are in sequence, you can't access them in single clock cycle. This is called misaligned data. Understand the concept? There is a concept called aligned data and misaligned data. Though 8086 can do 16-bit operation, but it can perform 16-bit operation in single clock cycle with only aligned data. Okay? With misaligned data, it will perform 16-bit operation, but it will be with 8-bit operation, 8-bit operation differently. First it will transfer this, then it will transfer this. The reason is simple. In address bus, at a single point of time, you can pass only one address. Okay? If it is aligned data like this, if I pass a single address, still I can access two different locations together because other than A0, everything is same. Yes? Yes. So, if I use my address bus carefully, A0 will decide which bank to select, odd bank or even bank. All other pattern will tell me which location to get selected, right? Yes? And that other part, A1 to A19, will be reflected in two different places. Yes? Throughout my memory. So I can access 16 bit of data in single clock cycle. Understand? Yes? Okay. Again. First question. Now, as we have discussed, this is called, one is called even bank with all even addresses, one is called odd bank with all odd addresses, right? Your even bank is also called lower bank, your odd bank is also called higher bank. Why? Can you tell me? Your even bank is called lower bank, your odd bank is called higher bank. Can you tell me why?
Even bank contain even address.
Yeah, but why it is lower bank?
Lower address.
Because if you contain, yes, Little Indian rule, lower address, lower byte, higher address goes to higher byte. Your even address is always 0, 1, 2, 3. So 2 will be lower, 3 will be higher. If you consider your aligned data, it is always containing lower byte. If I am containing 0, 1, 2, 3, 4, 5, 6, 7, these are my aligned data, right? If you consider this as aligned data, this is always lower address, this is always higher address, lower address, higher address, lower address, higher address. So even bank will always contain my lower bit data, higher bank will always contain my higher bit data. That's why your even bank called lower bank, odd bank is called higher bank. Understand? Yes? Clear? I hope so. Now, still, it is not over yet. It's just started. So, what is misaligned and aligned? Clear? Something on same line, aligned. Something on different line, page is not aligned. Right? Aligned pages is having only one address bit different. Which one is this? The Which one is that bit? A0. Other than that, everything will be clear. Okay. Now, this is my diagram. This is called chip select. If it is a bar, I need to pass negative. Yes, then that chip will get selected. Yes. What we have seen, if we use A0 for chip select signal, we can select odd bank and even bank, right? These are my A1 to A19 which is going into both the chips. This is my data bus P0 to D15 which is connected with both the chips. Now, if I put A0 here, so if A0 is 0, my lower bank will get selected. Done? If A0 is 1, in that case, you want to select odd. Done? Yes? Complete? It's not that way. It's not get completed like this. The issue is, if you A0 is 0, this will get 0, this chip will get selected. Here it is an inverter, so it will get 1, this chip will not get selected. If you are at 1, 1 goes over here, 0 goes over here, this chip will get selected, this will not get selected, right? Yes, because this is an inverter logic, right? So at any point of time, only one chip will get selected. This will not serve our purpose of accessing 16 bit. It is only accessing at a time 8 bit of data. But what I want both chips should get selected, even one chip should get selected, or other chip should get selected. Or if I don't want, nothing should get selected. Understand? આપણને એવું નથી જોઈતું કે ખાલી એક જ chip select થાય. What do we want? We want that both chips should get selected, or if I want to do only 8 bit operation, that should also happen. That should also possible, right? Yes. So this logic will not help in that. Only A0 pin will not help to decide odd bank or even bank. Okay. There are 4 different combinations. 1, 2, 3, 4. 1. I want to select odd bank. I want to select even bank. I want to select odd bank as well as even bank. Yes, and I don't want to select anything. I don't want to select even any memory location. Fine. If you want 4 different options, you minimum having 2 combinations. We know that in binary, one address bus can carry 0 or 1. So using one line, you can have only 2 combinations possible, right? If you need 4 combination, minimum how many lines needed? 2. 0, 0, 0, 1, 1, 0, 1, 1. Understand? So one line only is not sufficient to access your memory. So they have introduced one more concept called BHE bar. This is called bus high enable. As the name suggests, bus high enable, then it will activate higher bank. A0 will be used to access lower bank. Understand? This is how it will get connected. Now, understand, if A0 and BHE bar. Now, BHE bar because it is negative, it will get active on negative one, right? If both are 0, 0, what happens? A0 is 0. This chip will get selected. BHE bar is 0. This chip will get selected. Both chips are selected. A0 is 0. You can do both chip operation. 60-bit operation is possible, right? Yes. If A0 is 0, BHE bar is 0, this chip will get selected. This will get selected. This will decide which location to select. If it is aligned address, you can directly access 16-bit of data. Yes, and it is aligned address. How you can say that it is aligned address? Because A0 is 0, E1 address. It starts with E1 address, it is aligned address, right? So now you can do 16-bit operation in a single per second. Yes. Now if A0 is 1, BHE bar is 0. A0 is 1, this chip will not get selected. Only this chip will get selected. You can do 8-bit operation with higher value. Clear? Yes. If A0 is 0, my lower bank will get selected. A0, BHE bar is 1. Higher bank will not get selected. Lower bank is selected. Access 8-bit data from lower bank. Done? Yes. If both are 1, 1, nothing will get selected. Your CPU will be idle. Yes. Understand? So, this is your memory banking. Same is the concept with this. Now come to your original question from where we have started. Now, Can I make odd and even bank like this? 0, 1, 2, 3 in one part, 2, 3, 4, 5, 6 in other part. So half addresses are one part, half addresses in other part. Will it work? If you are having 1 MB of memory, can I have 0, 0, 0, 0, 0, 1, 2, 3 till 512 KB in one part and others are another part? Will it work? No. Why? Still you can't access two locations simultaneously. If you want to access two locations simultaneously, there is only one bit, one address bus that can make it different. Which one? A0. So what happens? If my A0 is 0, even bank will get selected. A0 is 1, odd bank will get selected, which is having same locations. Then only this concept is possible, right? So compulsorily you need to make odd bank and understand? Yes. This is 16-bit data. I want to access 16-bit data. That's why we are having two banks. Then Pentium comes. Pentium is having 32-bit processor. Then how many chips will be there? Like this. 8 चौको 32. 8 4s are 32. There are 4 chips. Okay. One will be 0, 0, 0, 1, 2, and 3. They will access 4 locations in a single clock cycle. Understand? Same concept. Now instead of A0, A0 and A1 both will be used. Yes. Now currently we are having 64-bit processor. That's why we are having this. Each chip is having 8 bit of data. At a time we can fetch from 8 different locations. 8 8s are 64. You can access 64 bits of data in a single clock cycle. Same banking concept. Understand? Yes. How will be the address? 0, 1, 2, 3, 4, 5, 6, 7. Yes. This is a line. But if you want to access 5, 6, 7, 8, 9, 10, it is misaligned. Same concept. Understand? Still it will access your, what you can say, 64-bit data, but in the background it will take more clock cycle. In a single clock cycle, if you want to do it, it must be aligned. Understand? Yes. Can you tell me why one location is having only 8 bit of data? We have seen that in each location of your memory is having 8 bit of data. Because it is the normal unit of measurement, 1 byte, right? So if you put 1 byte, if you want to store suppose 16 byte, you can store parallelly, like 11, 12, 16 bit data can be stored. If I want to store 32 bit data, 34, 55. This is my 32 bit data. Advantage of this method is I can store as big number as I want. If I want 64 bit data, I can store it in sequence, right? And no memory will get wasted. Understand? Another advantage is I can do 8-bit operation, I can do 16-bit operation. If I want to do 32-bit operation, I can do that also. Yes, if I put my memory with a bigger bytes, I will lose my bytes because I can't do smaller operations. A very small and basic example is during demonetization, we are having 2000 rupees note, right? What if your demonetization, like minimum note is currently we are having 5 rupees, right? What if that 5 rupee note becomes 2000 rupee note? The minimum amount that you can spend is 2000. Then, if you want to buy a tea, you need to spend 2000. Understand? ચાવાળા પાસે પણ રૂપિયા નહીં, તમારી પાસે પણ તમારા બે એમાંથી એક રૂપિયા જતા કરવાના. સમજ પડે problem? So demonetization should be small, but that doesn't mean that your maximum memory can't be more than 1 MB or 2 MB. It can be any. 2000 ની 500 નોટ પણ હોય, કરોડ નોટ પણ હોઈ શકે. 5 રૂપિયાની કરોડ નોટ પણ હોઈ શકે. You can have 5 crore rupees in form of 5 rupees note. No issue. Understand? So memory can be as big as possible, no issue. But the minimum amount of memory that you can store must be of 8 bit. Understand? So that you can do 8 bit operation, 16 bit operation or other operation. Yes? Now to do that operation, this is the concept that you are supposed to use. Clear? Thank you.